Alright, with a pen in your hand, let's get a writing. We got y is equal to x raised to the x power. So this is not one you'd normally see, but we need to know how to do it. Now there's a couple ways that you can do this. I use logarithmic differentiation to do this. There is another alternative, but maybe I'll post that someday on here. I take the natural log of both sides of the function. Now there should be parentheses around that. That's the natural log of our function there, x to the x. And then by the rules of the natural log, these are the properties of the natural log. I'm not taking the derivative yet here. You take the x, you can take the exponent and bring it out front. Now this is just the properties of natural log. We're not taking the derivative, okay? Now once I've done that, now I'm going to go ahead and take the derivative. So the derivative of y is 1, and then I just rewrite it. So you got to remember how to take derivatives of natural log functions. I've covered in some earlier sections. But the derivative of y is 1, and then you rewrite it. However, because we're taking the derivative of this thing with respect to x, when I take the derivative of y, I got to write y prime out here. Now this is really should be in the section on implicit differentiation. So if you just don't understand this, go to the section on implicit differentiation, and work these kind of problems out in there also. But anyway, so we write y prime is equal to, then I'm going to do the product rule here. So the derivative of x is 1 times, then rewrite, plus, then rewrite the first function, times, and then the derivative of the natural log of x, right? So the derivative of x is 1, and then you just rewrite x, or whatever this is, down into the denominator. And then, of course, we need to clean it up. And so we end up with natural log of x plus 1. So this all collapses down to 1 over here. But then what we need to do is we need to multiply both sides by y. So we get y prime by itself. So I do that. And of course we're going to go ahead and replace this y. Remember, it was equal to the x raised to the x. And we're done. Alright, so we got f of x is equal to x raised to the x minus 1. So I'm going to take the natural log of both sides, take the exponent, bring it out front, rewrite. Okay, so look at here. I haven't taken the derivative yet. This is just properties of the log functions. Okay, now I'm going to go ahead and take the derivative. So the derivative of the natural log of y. So the derivative of y is 1, and then you just rewrite. But then we got to tack on this y prime out here. Is equal to the derivative of x minus 1 is 1, and we rewrite. So this is the product rule here. Plus, right, the first function times derivative of the second function, derivative of natural log of x is just 1 over x. And then we need to clean this up. And so let's see here. I'm going to multiply both sides by y. And then substitute the y back in, or substitute back in the x raised to the x minus 1 because that's equal to our y. I don't know, it looks like I get a common denominator here. So I have to write an x over x plus, right, or x minus 1 over x, get a common denominator, and multiply the numerators now, add them together. So x times the natural log of y plus, then we have x minus 1 over here, and it's all over x. Now, you know, we could have stopped probably in that previous step, but I went ahead and did a little further some stuff. Took the x outside, then brought it up into the numerator, and then you add exponents, so we end up with x minus 2, and then just rewrite everything here. Here we're taking some derivatives and of some special functions. So we've got 1 plus x in parentheses all raised to the 1 over x. And what I'm going to do here is called logarithmic differentiation. And I'm going to take the first the natural log of both sides, and then I'm going to take this exponent and bring it out front. Now we're not taking the derivative just yet. This is properties of logarithms. So I'm going to take the exponent, bring it out front, rewrite, and now I'm going to go ahead and take the derivative. So we take the derivative of y, and we get 1, and then you just rewrite what's in parentheses, put it down here below, and then we got to tack on this y prime. Now I'm going to do the product rule. Take the derivative of x to the negative 1, so we take the negative 1, bring it out front, subtract 1 from the exponent, gives us negative 2, and then we rewrite the second function, plus rewrite the first function times and then the derivative of the natural log of x plus 1. So the derivative of x is 1, and of course derivative of 1 is 0, and then you just rewrite what's in parentheses down here below. So this is the product rule, derivative of the first times the second plus the first times the derivative of the second. And of course I have to mention this, sometimes they do it in a different order. They may write this first and then take the derivative of the second function plus and take the derivative of that and then rewrite, whatever. It doesn't matter. It doesn't matter at all which way you do it. Now what we need to do here is solve for y prime. So it looks like I take this x to the negative 1, I take it up here into the numerator. So we're just trying to clean it up just a little bit. And then, I get a common denominator. So I'm going to write an x plus 1 over x plus 1. And the reason for that is because I have an x plus 1 down here in the denominator. And then go ahead and join these two together now since we have common denominator. All right, so this is our new numerator here over x plus 1. Now I'm going to need to solve for this y prime still. Doesn't look like I do it just yet. What do I do? Oh, I factored out an x to the negative 2. So I pulled that out. And when we go to factor things like this out, right? So the base here, we have x to the negative 2 and x to the negative 1. Because both their bases are the same, right? We can factor these out, and you always choose the one with the smallest exponent. So we have a negative 2, so we're going to pull that out. So if I pull that out, we have a minus, and then the natural log of x plus 1 times x plus 1 plus, now I'm factoring out an x to the negative 2, so when I pull that out of here, we're just going to be left with an x to the first power. And the way to look at that is if I take this x to the negative 2 and I distribute it back inside, right, so I take x to the negative 2, and if I multiply it by x, remember we add exponents. And since x has degree 1, 1 minus 2 is a negative 1. So you can kind of think of it that way. And then I think I just switched these around here because I don't like that negative being right there. So we end up just switching places with both of these. And so I put the x over here minus. All right. And then I multiply both sides by y to get to y prime by itself. And then remember what y was equal to. It was equal to the x plus 1 raised to the 1 over x. So we want to definitely do that. We want to substitute back in. Then I took that x plus 1 and brought it over here on the left hand side. And of course that the x negative 2 that was up here in the numerator, I brought it down so we have positive exponent now. Now what I'm going to do here is I'm going to take this x plus 1, bring it up here to the top. And so I brought this up into the numerator, and then we're going to add exponents. So because both these bases are the same, 1 over x, right, plus the negative 1 or minus 1 here, however you want to say it, you just get 1 over x minus 1. And it looks like I left the x squared down here. Alright, and I think we'll just finish the problem there. So that was fun. We are taking the derivative of an absolute function, value function. I don't know, the absolute value of x. How's that? Um, so anyway, this is going to be our result here, but the question is, how did we get here? And I do have some kind of explanation going on here. Now remember, by the definition here, the absolute value of u is equal to the square root of u squared. So remember, we plug a negative number in to the absolute value, and it's really the absolute value function. Take it, plug a negative number in, and the result is a positive number. And that's what this is going on here. So I'm going to get this out of radical form and write it into exponential form. Now u inside here is a function, so this could be like, you know, x squared minus 1, or it could be x squared plus 1. So alright, so this d over dx means, okay, we're going to take the derivative of the absolute value of u, and the way this works is you're going to take, you're going to do the power rule. You're going to take the 1/2, bring it out front, rewrite what's in parentheses, subtract 1 from the exponent, so that gives us a negative half. Then you take the derivative of what's inside here, and derivative of u raised to the second power is 2u. But remember, now this u here could be a function, right? Remember, u could be x plus 1. So that means that we got to take the derivative, this is the chain rule part, we got to take the derivative of u and bring it out. And so I've written it as u prime. And then once we clean all of this up, we end up with u over the square root of u squared times u prime. And then I can replace the square root of u squared with the absolute value of u, because that's what it's equal to. So here's kind of our general formula that we're going to follow right here. So now remember, back in the original problem, this u here was just an x. Okay, so we take the derivative of u, or remember, u is equal to x, and so if we took the, to find u prime out here, if we take the derivative of x, we just end up with 1. And then, of course, u is equal to our x, and that's the absolute value of x. And, of course, we wouldn't leave our problem with 1 times, right? That just disappears. So there it is. Alright, so let's see if you can remember. So remember, this is our u up here, and then the absolute value of u, and then remember what the 2x is. The 2x is, well, I don't know, I kind of write it out here. So we got u is equal to what's in the absolute value, and then you take the derivative of u, and the derivative of x squared minus 4 is just 2x. And then we just use the formula. So u over the absolute value of u times u prime. Alright, let's run through this one here real quick. We've got this function f of x is equal to the natural log of x squared over x squared. So we're going to use the quotient rule, and that means that we're going to take the derivative of the numerator first. So the derivative of x squared, and normally I'd take this 2 and bring it out front before we'd even take the derivative of this, but I just left it like this. So the derivative of x squared is 2x, and then you just rewrite the x squared down here in the denominator times the bottom minus the top times the derivative of the bottom. Derivative of x squared is 2x, and it's all over the bottom squared. Alright, so we kind of clean it up. We end up with 2x minus 2x natural log of x squared over x to the 4th. And let's see, it looks like I factored out a 2x because we have a 2x over here, a 2x over here. Factored it out. And we can cancel, we have an x in the numerator, 4 of them in the denominator, so we can cancel one of those out and one out down here. And this is what we're left with as a final answer. So this kind of didn't match with the rest of the problems in this video set, but I don't know, I guess I threw it in here somehow. It got under the radar. But so that's how you take the derivative of some absolute value functions, and some strange functions and stuff like that. All right, thank you. Bye.